So what we'll do, we'll take a look at the two different feed waters separately. The first one that we will look at is the open feed water heater. So this is part of the regenerative Rankine. So with the open feed water heater, what we're doing is we're taking steam from the turbine and we're mixing that with the compressed water at state 2, and the mixture is coming together. Another thing that the open feed water heater does is it helps degasify the feed water. Remember we talked about saying that you can have corrosion within your boiler due to oxygen being present within the feed water. And with the open feed water heater, what we're able to do is by agitating through the injection of steam, we're able to liberate some of that oxygen or air that might be in the boiler feed water. And consequently, through this process, what we do is we reduce corrosion within the boiler, which is an important thing that we want to be able to do. So the next thing that we're going to do here is we're going to take a closer look at both the process schematic as well as the process diagram for the Rankine cycle using the regenerative with an open feed water heater. So what we have here is our process schematic and diagram. And this is very different from the Rankine that we looked at before for the reason that we're stripping fluid off at 0.6, which is coming out of our turbine. And what we're going to do is we'll introduce a new parameter here, and it'll be a little y, and it is going to be equal to the mass flow rate at 6 divided by the mass flow rate of fluid going into the boiler at 5. And consequently, what we will be able to do, we'll be able to say that this fluid stream here at 6 is percentage mass fraction y, and the fluid normally leaving our turbine will be mass fraction 1 minus y. And so we can carry that through. And then you'll notice that when we come into our open feed water heater, so let me just circle that, we come into the open feed water heater and we have fluid at y and 1 minus y. Those come together, and based on the way that we've defined the mass flow rate, when we exit there, we come back to 100% of the mass flow rate. So we then show, I'll put a little 1 here. Don't get it confused with state 1, but it's denoting the fact that we're back at 100% mass flow rate, and that is what this number 1 up here signifies. That is the mass flow rate of fluid going through the boiler, and we denote that as being 1. But then when we strip it off, we have to be able to have a way to account for the fact that we don't have the full mass flow rate. So that's what we're doing there. And then if you look at the TS diagram, one thing that I'll say, whenever you're drawing these, always make sure that you go to the saturated liquid point. That's always the starting point for any of these cycles, and it will make your life simpler if you ensure that you go to that point. So we go there, and with this idea of mass fraction y, what we have going from 7 to 1, we can write 1 minus y, and then what is going from 6 down to 3 is y. And so that would be the percentage of mass that we are stripping out and is then going into our open feed water heater. So that is the TS diagram as well as the process schematic with the open feed water heater. And what is going on here is pump 1. Notice that we have 2 pumps. That's right. We have pump 1 and we have pump 2. That's another thing that's different from what we've looked at before. And pump 1 does not take us all the way up to the boiler pressure. Pump 1 only takes us up to state 2. So it's taking us to the intermediate pressure, which is the pressure at which we're bleeding the steam off of the turbine. So that's an important point of the open feed water regenerative. So pump 1 is taking the liquid up to the pressure of the bleed steam. These 2 liquid streams are coming together and mixing in the open feed water heater. They need to be at the same pressure. So that's one point that you'll want to remember. So that is the introduction to the cycle. The next thing that I want to do, and it's going to take a little bit of time, is to take a look at the first law and apply it to the open feed water heater and see how the equations change from just the standard Rankine cycle. So that's what we'll do in the next segment.